Welcome to aminacademy.com. In astronomy, let us discuss about asteroids and planetary defense. Planetary defense is the effort to monitor and protect Earth from asteroids, comets, and other objects in space. Earth's gravity attracts more than 100 tons, more than 90 metric tons of small objects and dust from space daily, according to NASA. Most of these materials burns up in the atmosphere without any effect on the planet. Larger chunks may produce a bright streaks of light that's visible in the night sky or a small meteorite for a rock hunter to find. Earth's atmosphere, which is thick and protective compared with the more exposed surfaces of Mercury or the Moon, mitigates the dangers of these small collisions. But life on Earth has been drastically altered by asteroid impacts before. The Chicks Club crater, for example, is evidence of the planet shaking strikes that led to the extinction of the non-avian dinosaurs. Planetary defense system work to identify potentially harmful objects. Planetary Defense Coordination Office terminology. In proximity to Earth, while these systems have not yet identified or dealt with any major threats, NASA says. Today, telescopes around the globe scan the sky regularly to locate any bodies that are at risk of crashing into our planet. Meanwhile, researchers are developing ways to physically change the course of PHO to defend the planet from catastrophic collisions. Now, we'll discuss further detail about what is the asteroids and planetary defense. Planetary defense in astronomy focusing on detecting, tracking, and mitigating potential threats from asteroids and comets that could impact Earth. The primary goal is to prevent or minimize any harm to the planet and its inhabitants. This involves a multifaceted approach, including discovering and characterizing near-Earth objects (NEO), developing and testing the deflection technologies, and coordinating international efforts. Some key aspects of planetary defense: discovery and tracking. Identifying and monitoring NEOs is crucial for assessing potential impact risks. NASA's Planetary Defense Coordination Office (PDCO) plays a central role in this effort, using telescopes and other instruments to track NEOs and determine their orbits. Characterization: understanding the physical and properties of the asteroids, such as their size, composition, and internal structure, is essential for developing effective mitigation strategies. Deflection technologies. Various methods are being explored to deflect potentially hazardous asteroids, including kinetic impacts like NASA's DART mission and gravitational tractors. International cooperation. Planetary defense is a global concern requiring collaboration among nations to share data, resources, and expertise. Public awareness. Educating the public about the potential threat of asteroids impact and the efforts being made to address it is also an important part of planetary defense. Examples of recent development: NASA's DART mission. In 2022, NASA's DART mission successfully impacted the asteroid Dimorphos to test the kinetic impactor techniques for asteroid deflection. DART's NOR-DART Double Asteroid Redirection Test, that is DART, mission was the first ever demonstration of kinetic impact technology to deflect a potentially hazardous asteroid. It involved intentionally crashing a spacecraft into the asteroid's moonlet Dimorphos, which orbits a larger asteroid called Didymos, to test the ability to alter the asteroid's trajectory. The mission was deemed a success as it successfully changed Dimorphos' orbital period around Didymos. New Surveyor. NASA is developing the NEO Surveyor, an infrared space telescope designed to accelerate the search for NEOs. NEO Surveyor, formerly known as Near Earth Object Camera, is a planned space-based infrared telescope designed to detect and characterize potentially hazardous asteroids and comets that could impact Earth. It is a crucial component of NASA's planetary defense strategy, aiming to discover and track these objects before they pose a threat. The mission is managed by NASA's Jet Propulsion Laboratory and is scheduled to launch no earlier than September 2027. Planetary Defense Conference. Regular conferences bringing together experts from around the world to discuss the latest advancement in planetary defense. The need for planetary defense. Past impact. Historical evidence suggests that asteroids' impact have caused significant geological and biological changes on Earth, including the extinction of the dinosaurs. The last significant asteroid impact on Earth was the Chelyabinsk meteor event in 2013. This event involved a house-sized asteroid that exploded in the atmosphere above Chelyabinsk, Russia, causing the damage to buildings and injuring over 1,000 people. While smaller impacts occur frequently, the Chelyabinsk event was the largest recorded since the Tunguska event in 1008, 1908. Potential future threats. While the probability of a large asteroid's impact is relatively low, the potential consequences are severe, making it crucial to be prepared. Global impact. An asteroid impact could affect the entire planet, necessitating a global response. Asteroid impacts can have significant global consequences ranging from localized destruction to mass extinction. Large impact can trigger tsunamis, earthquakes, and widespread wildfires, while smaller impacts can still cause significant damage to the disruptions. The dust and debris thrown into the atmosphere can block sunlight, leading to a temporary impact winter and disrupting ecosystems. While large scale impacts are relatively rare, smaller impacts are more frequent and can still pose a threat. So far, we discussed about the defense system in meteors, um, asteroids, and planetary defenses. We have done. Please subscribe our YouTube channel.